Finish this exploration of equilibrium with a big example. It says starting at equilibrium and moving to a new equilibrium. For the following reaction at 500 Kelvin, we have an equilibrium mixture in a 1 liter container is found to have the following concentrations given here. Calculate the value of Kc. So here we've been given all of the equilibrium concentrations. We know that Kc is products raised to coefficients over reactants raised to coefficients. And we've been given enough information. So HI that number is going to be squared. And then we have two different concentrations. And I'll leave out my units because as much as I love units, units are not used in K expressions. I get Kc equals 50.0, which is, it should just be 50 probably, but we'll keep 3 sig figs. 50.0 is my Kc value. And then an additional 0.3 moles of hydrogen iodide is then added to the same total volume. What concentrations will be present when the new equilibrium is reached? Well, that's going to change the concentration of our HI. We know that we are adding 0.300 moles of HI. We know that we've got a 1 liter container. And so this is our new amount that we're adding. That's just a scribble. And then plus, we already had 0.490 molarity. So our new total is 0.790 molarity. And we can see that we've added product. That means that whenever we add that product, our QC value will now be larger than Kc. And we'll just multiply that out to show you how this works. 0.79 squared divided by 0.08 divided by 0.06. Our QC is now 130. That is greater than Kc. So shift left to get back to equilibrium. Now let's continue the calculations here. We now need a molarity ice table. We'll put in our reaction. Our reaction has H2 plus I2 goes to 2HI. We have initial concentrations of H2 is 0.08. Our iodine is 0.060, and our new concentration is 0.790. Now, the reaction has to shift left. If the reaction shifts left, that means we're going to do the reverse reaction, which means that the minus 2x's or the minus x's or whatever it is have to go on the product side, and the plus has to go on the reactant side. So that's totally fair game. That's what it means when the reaction goes to the left as far as a molarity ice table. So exciting. All right, well, I wonder how this math is going to work out. So filling in our values here. we can't do any approximations. Our k is 50. So we're going to have to solve the quadratic for this one, I guess. I'm ready. Kc equals products raised to coefficients over reactants raised to coefficients. We have 0.790 minus 2x squared over all of this in the denominator, and that all equals 50.0. So multiply all this out. It's going to get messy. 0.08 times 0.06 is 0.0048 plus 0.14x plus x squared, 0.08 plus 0.06 is 0.14. Shoo. Then that's going to be cross multiplying, so all this is going to be times 50, and we'll put it on the product or the right hand side over here. So 50x squared plus 0.14 times 50, 7x plus 50 times 0.08, 0.24, and then on this side it's going to be 0.79 squared, 0.624 minus 0.790 times 2 times 2. So because there are going to be two of these terms, and then plus 4x squared. Does that look like what I got so far? Huh? Well, let's check that again. So it's 0.790 minus 2x, 0.790 minus 2x. It's going to be 0.79 times 2. Yes, there we go. I'm exhausted. But we press on. Let's get all the terms. So we'll set this side to 0. So 50 minus 4 is 46. We have, all right, this was a plus, that's a minus. So that's going to equal 10.16x. And we have 0.24 minus 0.624, 0.384. So now we plug into the quadratic formula. Minus b, minus 10.16, plus or minus b squared, 103.2, b squared minus 4ac, there we go. So minus 4 times 46 times 0.384 gives me 173.8 under here over 2 times 46. 10.16 plus or minus square root of 173. 13.2 over 92. Take the positive root, 13.2 minus 10.16 divided by 92. 0.033 Molarity is my x. Am I still on screen here? Oh my goodness, there I am. So I now know my x. I can go back and plug it in. I'm going in overtime here. So let's see. Well, I think I can fit this in. We have concentration of HI equals 0.790 minus 2 times 0.033. .724 molarity. My concentration, and I'll just do this part in my head. So concentration of H2 equals my 0.08 plus my 0.03, so 0.113. My concentration of my I2, 0.093. Those are molarities. They're on screen. I think that's correct. I hope it's correct because it was a lot of work. At least my answer made physical sense. What I mean by that is I did not expect a lot of reaction to occur because I've taken then, oh, I can plug back in. Let's plug back in. So 0.724 squared divided by 0.113 divided by 0.093. 49.8. Thumbs up. I think I did it correctly. Miller, signing out.